Okay, today we're continuing with surface area and volume of three-dimensional shapes. To start with, we're going to go take a look at a little bit of vocabulary. A prism is a three-dimensional figure where the sides are made up of rectangles. So if we take a look at both of these are prisms. You can see each one of these sides around here, a rectangle, same thing down in here. And again, just to continue naming those. Remember, we name them according to the base. You can see it has a pentagon as a base, so we call that a pentagonal prism. If we look at the one down here, notice your base is right here, which is a triangle, so we would call that a triangular prism. Okay, then the bases of the polyhedron are the top and the bottom, or they are the two sides that are parallel. They are the two polygons that are parallel. So if you look here and here, the two sides that are parallel would be the triangles there. And oftentimes, if you want to think about, the bases are also the ones that we use to name it. So here we know they're a pentagon, here we know they were triangles. So the lateral faces are the other faces, faces other than the bases. And when we're talking about a prism, we said we know they have to be rectangles. The altitude is, and to me these are kind of one and the same. The altitude and the height are how tall the prism is. The lateral area of the prism would be all of these faces right here, or these three faces right here. It would be the surface area of the lateral faces. And then to get the total surface area, you're taking your lateral area plus you're adding in two of your bases, because you've got the top and the bottom, and those are always going to be the same thing. So again, if we wanted to write that out in words, it is the lateral surface area plus the surface area of the two bases. So let's go fill in a little bit of vocabulary right here as well. So if you take a look here, they're pointing to the top and the bottom. Those we said are the bases of the prism. If you can see here with these arrows, they're pointing to this right here, and they're pointing to this right here, which is the height or the altitude. And then here they're pointing to, it doesn't look like it is on that one, but I think they're trying to point to the sides of the prisms, which we said are the lateral faces. And then finally, there are two types of prisms, but we're mainly just going to deal with the right one. So the right prism is when your sides are rectangles, and it's truly standing upright. So in this particular case, these are right prisms. And then if you look at this one is kind of leaning off to the side. That one is oblique, and this particular one, when they are shifting off to the sides are parallelograms. And as I said, don't worry about the oblique. This is the main one that we deal with, are the right prisms. Again, this one is an oblique. Okay, so we're going to look for the surface area of the rectangular prism. I'm going to kind of show you two different ways. One would be similar to what we did yesterday, so I'm going to go ahead and show you that to begin with. I'm going to go grab a rectangular prism, which in this case is my Kleenex box. And let's go through and find the surface area of this box. So the first thing I would want to do is find the surface area of the top and of the bottom of the box. And if you notice, those are the same. I went ahead and measured this. So if I measured this one and I did it in centimeters just to be a little bit more accurate, I got 22 centimeters here approximately, and I got about 12 there. So just to find the surface area of the top box, I'll go grab my calculator, see if we can squeeze both of them in. I've got, we said 22 by 12, so 22 times 12, and remember the top and the bottom of the box are the same thing, and I get the surface area of the two bases is 528. Now the next thing I'm going to do is I want to go cover the sides of my Kleenex box. So again, we already figured out this length was 22. If I go and measure this one right here, I got it to be 9. That means I've got 12 times 9. Again, that's the two sides of the box, and I multiply that by 2. Now the last thing we need to do is go and cover the front and the back of the box. So again, we already know that this length here is 22. I would then have to go and find this height right here, which would be 9. So I've got 22 by 9 for the front and the back. So 22 times 9 times 2. And then finally, if I'm looking for the total surface area, I would go ahead and add all of these up. So let me zoom in. We've got then 528, 216, and 396. And I came up with 1,140. Now let's go look at it from using the formula. And if you've got your formula sheet, you'll notice that formula is on there. So let me grab my formula sheet. Let's go back to our notes. And I think what we'll do is just show you, let's go change these dimensions so they match up kind of the dimensions of our Kleenex box. We got this one to be a 22 centimeters. We had this one to be a 12 centimeters, and then we had a height of 9 centimeters. Now, whether I do it like I did by hand or whether I use my formula, I should end up with the same answer. Let me grab my formula sheet. I got my formula sheet. All of the formulas that we're going to be dealing with in this unit are down here, and they've been organized pretty well. So if they're looking for the lateral area, the surface area, and eventually we'll be getting to volume. So right now we're just going to deal with the prism. I see the surface area of the prism is P times H. P stands for the perimeter, H stands for the height, and big B stands for the area of the base. So I'm going to go ahead and put that formula down for us. Again, we had P times H plus 2 big B. And again, if we need to write a few extra notes for us, let's put that down as well. P is equal to the perimeter of the base. H stands for the height of the prism. And big B stands for the area of the base. So if you can kind of visualize, if I can draw this in, here is the base of that rectangular prism. So if I'm looking for the perimeter, I want to add up all 4 sides. So that would be 22 plus 12 plus another 22 plus 12. Let's go ahead and see what we get for that. I got 68, and then I want to multiply it by the height of the prism. Here is the height of the prism, which is 9. And I get 612. So if you think of what that has done, that's found all of the lateral areas. So in other words, I've covered the front of the box, the back, the left, and the right. The last thing I'm adding in is the top and the bottom, which again are both rectangles. Big B stands for the area of this base, which is this rectangle down here. So we've got 2 times 22 times 12. And we've got 528. Now again, hopefully we're going to end up with the same area that we did when we just looked at the surface area of each one of the sides. So I'm going to add these up, and I'm coming up with 1,140 centimeters squared for my total surface area. And that's the same thing that we got if we didn't use our formula. So you do have options. You can use the formula, or you can break it down like I did and find each one of the surface areas of each face and then add them together. Okay, let's move on to the next one, number 2. So on number 2, we've got a triangular prism, and remember, it's a triangular prism because the shape of the base is a triangle, and I know that because those two sides are the parallel sides and they're also congruent. Okay, in this particular case, we want to find the lateral area and the surface area. So if you look at your formula sheet, the lateral area is just the sides. That's the perimeter times the height. So let's go after that. And remember, P is the perimeter of the base. I know this is 3 and this is 5, but I need to go use Pythagorean's theorem to find that other side. So that other side would be equal to 3 squared plus 5 squared. And we're just going to go ahead and take that to a decimal. And we end up with 5.83. So my perimeter is 3 plus 5 plus 5.83. And the height of the prism is the distance that connects those two bases. So in other words, if you took that prism and you stood it up on its triangular base, the height would end up being 10. Okay, so plugging it all in, I ended up with 138.3, and that would be meters squared. Now they want me to find the surface area. If you look at your formula sheet, surface area is P times H, which is your lateral area, plus you're adding in the two bases. So I'm going to take this, I'm going to add in the two bases. Remember, we said our base was triangles, so that's 1/2 base times height. The base of that triangle is 5, the height of that triangle is 3, and finally we're going to add those together. And we end up with 153.3 meters squared. Okay, the second one we're going to look at then today is a cylinder. A cylinder is really kind of like a prism. The only difference is its base is a circle. So a cylinder is a polyhedron with circular bases. So we said these are circles. And then the lateral area. If you can think about, if I can find a piece of paper here, if you think about a cylinder, let me zoom back out for us. So a cylinder is like this. You can see that roughly. So if you think about when you open up that piece of paper, this distance right here with regards to that cylinder is actually the circumference, and this length right there would be the height. Again, if you look at your formula as well, I'm going to that formula sheet, it says lateral area of a cylinder is 2 pi RH. Here we're talking the top and the bottom of these are the bases, and these are both right cylinders. As I said, we're not going to worry about the oblique.